Okay, so in this video we're going to be answering an exam style question on A-level organic chemistry, free radical substitution, and this is for the WJEC chemistry A-level new spec. So let's have a read of the question. So it says chloromethane can be produced by the chlorination of methane gas. During the initiation stage of this process, chlorine free radicals are produced. Give the conditions required for this initiation stage. Now, because we're talking about an initiation stage and producing some sort of radicals, we know that this is the mechanism free radical substitution. So I'm just going to write that down on the side for my own reference, so I don't forget later on in the question. So that is free radical substitution. Okay, so the conditions required. So we know for an initiation stage in free radical substitution, we need ultraviolet light. So that's our answer. So ultraviolet light. So I'm just going to put UV in brackets here for short. Second part, state what is meant by free radical. So that's another definition question. And we should know that free radical is a species with an unpaired electron. So I'm just going to write that down here. So that's species with an unpaired electron. That's our definition of a free radical. So part B. Write the equations for the propagation stage to produce chloromethane, starting with methane and chlorine free radicals. So before propagation we have initiation. So even though the question doesn't ask it, I'm just going to write the initiation stage down for my own reference. So initiation is where we started the chlorine gas, and we know that's diatomic, so that's Cl2. UV to break that chlorine bond, where we produce chlorine radicals, two of them like this. I'm just going to put that in brackets. So now propagation, the first reaction, we would use our chlorine radical, react it with methane, which is CH4, an alkane. This chlorine radical is highly reactive, so it wants to gain one of these from here. So it'll take the hydrogen to complete outer shell, so that'll be HCl. And because methane's lost one of the hydrogens, it's going to become a radical now, so that'll be a methyl radical. And then the second part, this methyl radical will react with chlorine gas. So this is obviously very reactive now. So that's when I want to get one of those chlorines, so that'll be CH3Cl plus, and I'll leave chlorine as a radical now, so that'll be chlorine as a radical here. So that's the two steps for the propagation stage, and we didn't need the initiation here, but I've just put it just to get the question started. So the final part of the question says, apart from chloromethane, a range of other compounds are produced in small amounts during this reaction. One of the compounds produced in the reaction is ethane. Show how this compound is produced. So this is going to be related to the termination stage. Termination stage. And this is really where any two radicals can actually react together. So whilst it could be a methyl and a chlorine radical, it could equally be two methyl radicals. And that's exactly what's happening here. So I'm just going to say that 2 CH3 radicals combine in the termination stage. So that's the question. So that was on free radical substitution. So I hope that was helpful. Make sure that you like and subscribe so that you don't miss a single video. If you have any topics that you'd like me to cover an exam style question on, then also leave a comment for that. Other than that, I hope that was helpful, and I hope you have a nice day.